Hey everyone, welcome to Dr. Ravi's Academy. I'm Dr. Ravi, Professor of Mechanical Engineering. In today's lecture, you will be understanding how to derive the expression for shear stress. For that purpose, let us consider a rectangular element ABCD and cut a plane at an angle phi with the vertical line CD, that is ED, and draw the element. The magnified view of the element is this, and represent all the stresses, that is sigma x along the x direction, sigma y along the y, and tau xy, both the components along x and y directions. And where you have cut, there you are representing the normal stress and the shear stress. This is also known as tangential stress. Now we are interested in deriving the expression for the tau, which you have represented towards E. And I am converting the stresses with the multiplying with appropriate areas as forces. And I am assuming the thickness is unit thickness. So let us multiply with the appropriate areas to convert the forces, and all these forces are represented on coordinate axis along x and y direction. Now, this particular element is in equilibrium under the action of the forces, and which you have converted stresses into with multiplying the appropriate areas. Now, let us take here it is this is your normal direction along this normal stress, and perpendicular to it along this ED, your tangential direction. I would like to write the sum of the forces along the tangential direction T. So let us see, it is sigma Ft is equals to 0. Sum of all the forces along the tangential direction is 0, and it is a tau into ED, which is positive, and these two components, 1 2, these two components of these two also positive. I am writing it as plus tau xy into CD, that is one force, plus sigma y into EC. So these the two forces I have represented along this line with the cos component. You see, the component becomes, it is cos of phi, because the component is cos phi. Here also it is cos phi. And let us see the forces along the normal direction. Here it is along the tangential direction, these two components, and these two are become sine component. So that becomes minus, because the other side of this tangential direction minus, I am writing it as sigma x into CD sine phi, because the component is minus and it is sine component, minus tau xy into EC sine phi is equals to 0. This is my sigma Ft is equals to 0 equation. Now rewrite this term the other side, and let us rewrite it is a tau into ED. I am keeping tau left hand side, and all the other terms I am bringing to the right hand side. It is minus tau xy CD into cos phi minus sigma y EC into cos phi. This becomes plus sigma x into CD, it is sine phi, plus tau xy EC into sine phi. Now divide with the ED, with the right hand side terms, divided by ED, divided by ED, divided by ED, and divided by ED. Let us consider the triangle CDE. From this right triangle, you can write down cos phi. Cos phi is equals to, it is adjacent side CD by ED. So it is CD by ED is cos phi. Similarly, you can write down what is sin phi. Sin phi is equals to, it is opposite side EC divided by hypotenuse ED. So let us substitute sin phi and cos phi values into this and further simplify, you have it is minus tau xy, tau is equals to CD by ED. It is CD by ED is cos phi. Already you have one cos phi. This becomes cos square phi. Again, it's minus sigma y into EC by ED, that is sin phi. So this becomes sin phi into you have cos phi. Your third term is sigma x into you have CD by ED. CD by ED is cos phi. You have sin phi into cos phi. And the last term, that is plus tau xy, here CEC by ED is sin phi, that becomes a sin square phi. Now let us take the terms common. Tau is equals to, here you see that tau xy, you could take minus, it is this first term you can write down sigma x minus sigma y. I am dividing it by 2 and multiplying with 2. So you have 2 sin phi and cos phi. So this and this, I have taken two terms. The other terms, let me take minus tau xy common, so that you have cos square phi minus sin square phi. And the last step, that is tau is equals to is sigma x minus sigma y by 2 into sin 2 phi minus tau xy. As you know that cos square phi minus sin square phi is cos 2 phi. So this is the required expression for the shear stress, which is also known as a tangential stress. Usually, we will be asking you to calculate the resultant of normal and shear. Then it is the resultant stress. I am writing sigma r is equals to, you can write down sigma square, which is the normal stress, plus tau square under root, so that you can calculate the resultant stress at any angle phi with vertical plane. Thank you.